So for today, we'll concentrate on the rational functions. So first of all, we need to know what are the rational functions, right? So I can say that a rational function is a function of the form which is f of x is equal to what? Which is equal to ax over bx, right? Where ax and bx are what? Are polynomial. And which is bx, right? Is not equal to what? Is not equal to 0. So that's what we call rational function. So a rational function, this is how a rational function looks like. So examples that I can say are the examples of the rational functions, right? So examples I can say we have one. Okay, let me just do this. So examples I can say you have what? We have what? Examples I can say you have y is equal to 1 over x, right? The next one, it's what we call, the next example I can say y is equal to 1 over x what? Squared. Then the next example is what I can say x plus 1 over x squared plus 1. So these are the examples of rational what? Functions. Minus 1 there, right? Or cubed x squared plus 1 plus x plus 1. So these are all examples of the what? Rational functions. All right? So if these are the examples of the rational functions, now the first thing is, since we're still looking at the rational what? Rational function. So if these are the examples of the rational functions, meaning that we need to know how the graph of this rational function will look like, right? So how are we going to know the graph? So the graph of the rational functions, it follows these, the things that you need to know when you are finding the graph of the what? Of the rational function. So the first thing that it follows is what we call the horizontal asymptote. Is it okay? And again, it follows the what? The vertical asymptote. Is it okay? So let's start with the first thing. The first thing we start with what? It follows these. These are the rules that you need to do when you are plotting a graph, or you're sketching the graph of the what? A rational function. You need first to find the what? The vertical asymptote. Vertical asymptote. Then the next one, it's what we call horizontal asymptote. Then the third one, or the rules that you need to take note of, the third one, it's you need to check the degree of the what? Of the numerator and the degree of the denominator. So these three things are the things that you need to be checking whenever you are about to plot what? You're about to plot the graph of the rational function. You have to first to find the what? The horizontal asymptote, the vertical asymptote, and also check out the degree of the numerator and the denominator. How these two correlate. Is it okay? So those are the main things that you need to take note of. So in this situation, how do we find the vertical asymptote? The vertical asymptote, we solve the denominator. Example, how do we find the vertical asymptote? For example, you have we have this. Okay, let me just say the examples in short, right? The examples on how you can solve the what? You can graph the rational function graph. So they'll tell you that sketch, right? They'll tell you sketch the graphs of the rational function, of the rational what? Functions. So the first one, they can say the first one, they say y is equal to 1 over x, right? The second one, let's put y is equal to, now I've put the negative there, right? 1 over x like that. Is it okay? Then the third one, let's say positive 1 over x. Now let's put squared like that, right? Then the fourth one is equal to, more examples will come after that, after knowing so just these two things, because this, if you know just to graph these two, meaning that it will be very easy for you to graph any graph that you can be given on the what, on the Russian function graph. So let's start with the first one. On the first one, say y is equal to 1 over x, like that, right? Now the first thing that you need to check up is what we call the vertical asymptote, right? Then after checking the vertical asymptote, we go to the horizontal what, asymptote. Then that's when you can check the what, the degree of the numerator and the degree of the what, denominator. Is it okay? So in this situation, let's start. In this, how are you going to find the vertical asymptote? So the vertical asymptote, in this way, you get the function of the denominator. What's the function of the denominator in this on this point? The function of the denominator is x, right? So you say x, you equate it to what? To 0. So we solve the x. So in short, here x is equal to 0. So meaning the vertical asymptote in this situation is what? It's 0. How about the horizontal asymptote? So the rules when you're writing the horizontal asymptote are these, right? So the rules are when the degree of the denominator is greater than the degree of the numerator, meaning that the horizontal asymptote is equal to what? To 0, right? When the degree of the denominator is greater than the degree of the numerator, meaning that the horizontal asymptote is equal to what? To 0. What do I mean if I say like that? So here I meant that. For example, this is your equation, right? This is 1 over x, right? So what's the degree of the denominator in this equation? It's 1. But what's the degree of the numerator on top? It's 0. Why I'm saying it's 0? Because this is just the same as x to the power 0. The down part is x to the power 1. So on the denominator we have x to the power 1. Then on the numerator we have x to the power 0. Such that on the numerator we're having 0. On the denominator we're having 1. Such that the denominator is having the greater degree than the numerator. So in this situation, the horizontal asymptote is what? It's 0. So how are you going to draw your graph? Your graph you plot in this way. Now in this situation, what is your horizontal asymptote? So what is your horizontal asymptote in this situation? The horizontal asymptote is 0. So meaning that you plot where it's 0 like that, right? That's the point where the horizontal asymptote is. It's there, right? How about the vertical asymptote? The vertical asymptote is this side. So now here we need to test these values, right? We need to test these values. So how do we test these values? We test these values by, the first thing that we need to do is to get the number. This is 0, right? Let's get the number that are less than 0. So we have negative 1 there, right? So this side is what? Positive 1. So here on this video, we'll just be concentrating on two things, right? If this side, this is negative, right? Yes, the y-axis is negative, but this side is what? Positive, right? Then this side, which is of the y-axis, the y-axis this side is what? Positive. Then this side is positive for x-axis, then the y-axis this side is what? Negative, right? So we'll just be concentrating these signs, only the signs on this video. So let's test these values, right? So when you're testing these values, let's get 1 after the what? The vertical asymptote. Let's get the 1 before the vertical asymptote, which is the numbers that are less than what? 0. Let's get it. The numbers that are less than 0, we're having negative 1, negative 2, negative 3, just like that, right? So in this situation, you are going to test. So you are going to say y is equal to 1. Let's get the numbers that are less than 0. Yeah, it's 1, right? So you find that your answer is negative 1. So where is negative 1? Where is negative 1? Negative 1 is downside here, right? To the y-axis, which is negative 1, which is here, right? Right? So in this situation, you can just conclude that your graph will come from this side and it will pass to the point where it's what? Negative 1, which is there. Just like that, right? How about after 0, or the numbers that are greater than 0? When you test them, it will be 1 there, then positive 1. What will be your answer? Your answer will be 1. So meaning that it will be 1, 1, right? So 1, 1 is here, meaning that your graph will be like this. So this is how your graph will be, right? So that's how you draw your graphs. Is it okay? Let's do the other question. The other question, it was negative 1 over x, like that, right? The first thing you need to find is the what? The vertical asymptote. So what's the vertical asymptote in this situation? The vertical asymptote is 0, like that, right? Then what's the next thing? The next thing is the horizontal asymptote. You check out the degree. The degree of the denominator, is it greater than the degree of the numerator? Yes. So mean that the horizontal asymptote here is what? 0, like that. Then let's plot our horizontal asymptote in this situation. It's 0. Our vertical asymptote, it's 0 again. So meaning that, let's test out the numbers that are less than 0 is negative 1, Also test the number that are greater than 0, it's 1 there, right? Then let's test. So if you say y is equal to negative 1 over x, like that, right? Then you say negative 1 over 1, then this is x. So meaning that you have gotten the number that is less than 0. After getting the number that is less than 0, I've gotten 1. So it will be positive 1. So negative 1, it will go to positive what? Positive 1 in the y. So meaning that the graph is somewhere here. So meaning your graph will move from this side, will go like that. Is it okay? How about the other one? Let's test again. Now we have to test with 1, right? So we're going to say y is equal to negative 1 over 1. So meaning that your y will be negative 1. So where is it? Positive 1, positive 1, negative 1. So positive 1, negative 1 is here. So meaning that your graph will move from this side and it will go this side like this. So this is how your graph will be. Just like that, right? So those are the ways that you can be using these things, right? Now let's go into another question. The another question was y is equal to negative 1 or positive 1 over x squared, right? This is the rational function, right? 1 over that. What's the horizontal asymptote? Oh, first of all, what's the vertical asymptote? You get that x squared is equal to 0, then x is equal to what? To 0 still. So the horizontal asymptote is 0. How about the vertical? Oh, this is the vertical asymptote. How about the horizontal asymptote in this situation? The horizontal asymptote in this situation, you check out the degree. The degree, is it greater or the degree is less than? The degree of the numerator. Is it less than 1 or is it less than the degree of the denominator? So you find that the degree of the denominator is still greater than the degree of the what? Is still greater than the degree of the numerator. So meaning that your horizontal asymptote is what? It's 0 like that. So let's plot this. The vertical asymptote, the horizontal asymptote, like that, right? So in this situation, what are you going to do in this situation? Let's get the numbers that are less than 0. We test them, right? Let's test the numbers that are less than 0. So this is 1 over x squared. So I've gotten negative 1. Let's get negative 1. It is still giving us positive y, right? This is positive 1. So I mean it's still giving us positive y. Why is positive y? The positive y is this side, right? Okay. Then get again positive 1 this side. It is still giving what? 1, positive 1. So it's still giving out positive 1. So meaning that all of them will go like this. Because this is the positive y, where positive y is. Just like that. Is it okay? How about the other one? Do the same thing. The vertical asymptote in this situation is 0. Horizontal asymptote in this situation is what? It's 0. Then let's plot. So the vertical asymptote and the horizontal asymptote, right? So in this situation, the horizontal asymptote is 0, then the vertical asymptote is 0. Meaning that what are you going to do? What are you going to do in this situation? In this situation, let's test, right? Let's test. So how are we going to test? Let's get the number that is less than 1 or less than 0, which is, well, I've said it's y is equal to 1 over. That's negative then x squared. Now, after putting your negative 1 squared, you find that your answer still to be remains what? Positive. So your y now is still positive. Why is the y positive this side down? So meaning that your graph will go down like that. Remember, it must not cross the vertical asymptote. Then you also do the same thing. You get the positive 1, which is this side. Your answer still give a negative 1. So your y still remains to be negative. So if your y still remains to be negative, meaning that it will go to this side again. So that's how we plot this type of graphs, right? Now let's look at deep examples now, right? Let's look at deep what? Examples. Let's look at deep examples, right? So in this situation, so let's look into deep examples now. So the first example that I can say, they will say we're still sketch, right? We're still sketching, right? We're still sketching. So the first example that I can say, they'll say sketch this type of a graph. It's 2x minus 11 like that, right? Is it okay? Over x squared plus 2x minus 8. So what do you do in this situation? The first thing that you do in this situation is finding the what? The vertical asymptote. So how do we find the vertical asymptote? We get the denominator. What's the denominator in this situation? It's x squared plus 2x minus what? Minus 8, right? Is equal to 0. So in this situation, we look at product sum fact. So what's a product in this situation? The product is 4 and what? Negative 2. So you solve there, right? So meaning that your x is equal to negative 4, then the other one x is equal to what? To positive 2. So meaning that the vertical asymptote in this situation, it's x is equal to negative 4 and x is equal to what? To positive 2. Then what's the horizontal asymptote in this situation? The horizontal asymptote in this situation, you check out the degree. The degree of the denominator is 2. The degree of the numerator is what? It's 1. So meaning that the horizontal asymptote in this situation is continues to be what? 0. Then what do you do? What do you do in this situation? We plot out now, right? We plot this graph. So the vertical asymptote, the first vertical asymptote is negative 4. Then the other one is what? Is positive 2. So you draw there like that. Right? Then what do you do now? Let's test these values, right? Let's test these what? Values. Okay, first of all, what's the horizontal asymptote before you go anywhere? The horizontal asymptote is like that, right? Let's test out these values, right? Let's test out these values. So how do we test these values? That's where we have to say what? We get the numbers that, so the numbers that are less than 4. What are the numbers that are less than 4 here? It's negative 5 there, right? Let's put negative 5 everywhere where there's x, right? So this side is positive y and this side is negative y. Once we find positive y, meaning that we'll plot the graph this side. Once we find the negative y, then the graph will go this side, right? So let's do that. Y is equal to 2, the negative 5 there, minus 11 over, which is there, plus 2, 5 there, minus 8. Then you find that, let's see, that's your what? Negative. That's your negative what? That's your negative 10 minus what? Minus 1. Minus 11, sorry. Minus 11. So over, let's see, positive 25. Positive 25 times, that's negative 10 minus 8. Then there, that's negative what? Negative 21. Over, this is 25. Then that's 18. So 25 minus 18, it will give you 25 minus 18. That's positive what? Minus 18, that's positive 7. Right? So meaning that the answer will still come up to what? Negative. So meaning that it's negative, right? We'll find that it's what? Negative. So if it's negative, meaning that the graph will be to the negative what? To the negative 1. So which part is negative 1? This is the part that is negative 1. There, like that, right? So that's how we test that. Then let's test the numbers that are greater than 1. Okay, let's put here, we can put what? We can put negative 1. Then this side we can put 1, right? So we can test these two. So we have 2, negative 1, minus 11. Then that's the negative 1 squared. 2 there, negative 1, minus 8. Then that's negative 2, 11 there. That is positive 1, positive 2, then negative 8. Then what you're going to get, that's the negative 13. Negative 13, right? Then there, that's 1, that's 3, then negative what? 5. Then negative 5. Negative 13 divided by negative 5, it will give us positive. It has given us positive, so meaning that it's there. Okay, what will happen to the other one? Do the same thing. It will also give you positive, right? Because that's 2. So it will also give you what? Positive there. So meaning that it will get 2 now. 2 there, 11 there, then 1 there, that is squared, plus 2, then 1 there, that is 8. Then that is what? That is negative 9 over, that is still the same, that 1 plus 2, then 8, it will still, that's 2, negative 9, then that's negative 5, then that's be positive again. So meaning that your graph will come like this, goes like this again, right? Even if you test this side again, it will give you the negative, meaning that the graph will be like this. So this is how you do. So here, what am I doing? I'm just looking at the signs, right? So after you have tested the numbers that are less than negative 2, it has given you a positive or a negative. It has given a what? A negative, meaning that you plot where there is y-axis, which is what? Negative. Here I've done the same thing. Here both of them I've gotten the number that are less than negative, or the numbers that are greater than 4, I've gotten negative 1. It has given me a positive. So I'll plot a graph where it's what? Positive 1. Even this side again, I'll do the same thing. Just like that. So that's how you answer that. Is it okay? So that's how you answer that, right? So let's do the other example. The other example, it is this one. So the other example that I can say it's that's question 2, right? So I can say f of x is equal to what? X plus 1 over x minus 2, like that, right? So that's another example. So in this situation, how are you going to draw this type of the graph? Let's check out the vertical asymptote in this situation. The vertical asymptote in this situation is what? Because that is x minus 2 is equal to 0, right? Then x is equal to 2. So meaning that if x is equal to 2, your x is equal to 2, like that. Okay, that's the vertical asymptote. Then how about the horizontal asymptote? Check out the degree. The degree of the numerator and the degree of the denominator, they are the equal. So meaning that what I'm going to do, you divide those degrees, right? So degree, that's x divided by x. What's your answer? Your answer is 1. So meaning that your horizontal asymptote in this situation is what? It's 1. Then you go on your graph. What's the vertical asymptote? You find that it's 2. So you plot there, that's 2 there, right? Then what's the horizontal asymptote? We find that it's 1. Then you plot there, right? Then after doing that, meaning that you also check out the what? Let's plot now. After testing, you find that this side, after getting 1, you find that this side it will be what? Negative, right? So after finding that negative, you will be plot your graph like that. Then after checking this side, after getting 3, you find that this side is what? Positive. So meaning that you come like this again. So this is how your graph what will look like, just like that, right? So that's how you solve those type of the graph. Then how about another example? Another example where you are having a situation which is like this. So the vertical asymptote is just the same thing that you do vertical asymptote, right? So what are the product sum factor in this situation? That's 3 there. Then x positive 2. So mean that your x is equal to 3 and x is equal to negative 2, right? So those are the things there, right? How about the horizontal asymptote? So horizontal asymptote in this situation, the degree of the numerator, is it the degree of the... Those are the things that we need to look at, right? Is it okay? Then you find out that it's still what? 0, like that. Now let's plot out this graph. You test there again, that's negative 2. That's what? 3. Then there it will, that's a what? A vertical asymptote. That's a vertical asymptote there. How about the horizontal asymptote? Like that, right? So you test out again, right? So if you test the number that is negative 3 there, you get a negative 3. You find that your y is what? Negative there. You find that your y is negative. Then you also test out the numbers that are less than there. The numbers that are greater than, you get 1 there, right? You find that it will what? A positive number. How about this side again? You find that your answer will be what? Negative. In short, it will be negative. So meaning that your graph will go in this way. Is it okay? Because even if you get a 0 here, you put a 0 here, to be somewhere here. So meaning that your graph will be go like that, right? And the other side again, you get a number that you will find the y to be positive like that after testing. Is it okay? So you have to be testing, getting the numbers that are less than 2 here, and get the number that are greater than 2 there. Then there again after 0, then even this side again, the numbers you have to get 4 there, right? You'll find that your answer will be positive, just like that. Is it okay? So this is how you plot this type of the graph. Now we have a situation whereby the degree of the denominator is less than the what? The degree of numerator. So what do you do in this situation? So in this situation, if you're having the degree of the denominator is greater than the degree of the numerator, so in this situation we have what we call oblique. Oblique what? Asymptote. So, or I can say slant, right? So we have what we call slant, right? So in which circumstances I can say that in a circumstance where you're having something like this, y is equal to x cubed plus 1, right? There, right? Then we're having x plus 1. So in this situation, that's where we have one at oblique what? Oblique. Is it okay? This is the situation. right? So this is the situation, right? Or I can say that x squared plus 10x minus 1, like that, right? So all of these, they'll give us the what? The oblique or the slant graphs. So how does this happens? This happens after you have solved the oblique function, right? So meaning that we need to, in this situation, what we need is, we need to solve these by the long division, right? So example, the one that we had there. Right? It was, how was it? X squared plus 1. Like that, right? Now, we divide this by long division, right? So meaning that we have x cubed plus 0x plus, oh, x squared there. And plus what? X plus 1. The x plus 1, right? Then x into there, x into here is what? X into here, that's x squared. Then that's x cubed plus x squared. Then what's the answer there? That's 0, right? After subtracting, then that's what's the answer? That is x squared there, right? Then x into there, that is x, right? That is x squared. Oh, sorry, it's supposed to be negative. Sorry, that's x squared minus, this is 0 and this is positive x, right? Then x, this one comes down, right? X into x, that's 1, right? Right? So in this situation, we don't have an oblique because this is the factor. Like that, right? So mean that is x there. This one. So in this situation, we don't have an oblique. What are we having? We're having what we call the whole. So this is here. So in this situation, you will do like this. You're having a whole. So meaning that y is equal to x squared. You get this part which is there, minus x plus 1. Then what's the factor x plus 1 over x plus 1? That this and this, they'll divide. So meaning that you can only find this graph. That's all. Is it okay? There. Then when an oblique comes, I can say that an oblique can come in this situation. Like that, right? So this is just the same as 2x squared then 4x plus 5 over. So first of all, you use the long division. The x there, that's it. Negative x squared, right? This time that, or just x, so this time that, let's see. Oh, that's 2, sorry. This time that, let's see. Positive 2x squared minus 6x. Right? So from there now, you subtract everything. That's 0, then let's see. Positive 2x. Like that, right? Then you bring down that. This into there, that's what? 2. Then that's 8. That's 5 there, right? Positive 5 there. Right? Then that into there, let's see. Positive x minus 6. Then what's the answer there? What's the answer there? In this situation, the answer there is 0. Then that's what's the answer there? Yes, what's your answer there? The answer here in this situation will be positive 11. So this is a graph that will be our oblique function what graph. So meaning that when you're plotting in this situation, right? When you're plotting in this situation, what you look at the oblique, right, graph. Now let's plot this graph which is here, right? When you plot that graph which is there, meaning that we have something that is there and here, it will pass in this way, like that, right? So that's how it will pass, like, right? Then what's a horizontal asymptote? This is your what? The horizontal what? Asymptote, like that. Oh, what's your vertical asymptote in this situation? What's your vertical asymptote in this situation? The vertical asymptote is what? It's x is equal to 3. So where is x is equal to 3? Maybe it can be somewhere beside. So meaning that it will, okay. Without that, you can just draw to be like this. Like that. That's how the graph will look like.